Good afternoon, everyone. My name is Mahesh Unnikrishnan and my colleague Amit Veermani. Today we're going to be talking about basically giving you a high-level overview of the storage management capabilities in VMM 2012 SP1. So the 2012 SP1 release is essentially an additive release, and it sort of builds on a lot of capabilities that we added in the VMM 2012 release. So at some points in time during this talk, we will refer to some capabilities we added in 2012. And we'll also talk to you about certain refinements and certain improvements we made in the next release in SP1.
Only regarding VMM today, not DPM or such things?
No, just VMM. This is not a DPM session. All right. So this slide essentially gives you a high-level overview of System Center 2012 VMM and our investments. They've generally been in 4 pillar areas, essentially in infrastructure management, configuration and management of the fabric, and we refer to the fabric as compute, storage, and networking resources. And then the ability to essentially create clouds on top of that, so you get a nice level of abstraction on top of your resources, and self-service users can essentially deploy their VMs and services to the cloud without really understanding what underlying host those VMs are deployed on. There's also the notion of services, which was introduced in VMM 2012, and it's really a great way to model your app. You can model like a multiple tier app, say a 3-tier app with a web tier, a middle tier, and a backend database tier. And you can sort of use services, infrastructure, and VMM to scale up each of these tiers as required. So as you have demand, you can scale up or scale down your infrastructure. In the infrastructure piece, or the infrastructure pillar, we focused very heavily on PowerShell. So there's about 452 commandlets, and we focused on making every aspect of VMM configurable through PowerShell. So every single thing that you can do from the UI can be automated using PowerShell commandlets. There's the ability to configure VMM itself as an HA, or a highly available server, so you can deploy it on a failover cluster. On the fabric side, we essentially focused heavily on managing hypervisors, both Microsoft's Hyper-V hypervisor as well as VMware and Xen. In the network management space, we did a lot of steps with the first VMM 2012 release with the ability to essentially allocate IP addresses and MAC addresses out of pools. And now we're building on the momentum of Windows Server 2012 to sort of build network virtualization capabilities into VMM. Now, this part of the talk is essentially going to focus on the storage management aspects. So we're really going to focus on the capabilities we added into VMM to manage diverse sets of storage, and we'll walk through that in this talk. The third pillar that we focused on was clouds, the ability to essentially create this abstraction over your fabric and essentially assign it to self-service users. Self-service users can deploy their VMs and they can consume resources from the cloud depending on quotas that you configure for that cloud or for that self-service user. And then services essentially allow you to basically define your app, deploy it, and service it using this well-defined template, which we call the service template. So with that background, let's sort of focus on the fantastic 12 of VMM storage, as we sort of refer to it. Over the next few slides, we'll walk through each of these and sort of talk to you about the enhancements we've made in VMM. Some of it builds really on the functionality that we added in the VMM 2012 release. A lot of it is just the logical evolution of some of that capability. So let's actually look at end-to-end mapping, right? A lot of feedback that we've gotten from administrators is it really gets really complicated when you start deploying at scale. You have a lot of storage options, you have a lot of virtual machines, hosts, and you really need to have a good way to look at a virtual machine end to end, right down to the storage or the array on which it is located. With Windows Server 2012, you have another option in the mix where you have the ability to essentially deploy your virtual machines over SMB storage. So Hyper-V now supports the ability to deploy your VMs on SMB shares. So we've invested a lot in VMM, and primarily our investment was guided by this feedback that we heard from customers. A lot of it is, I don't really have visibility into storage from the different management tools I use. In certain cases, you sort of use VMM and a bunch of other tools for virtualization management, and then you have a whole diverse set of storage management tools. Sometimes you have multiple disparate arrays, so you have different set of tools for each of those arrays or each of those storage devices. So it's really difficult to get visibility from an end-to-end perspective. And that really is the second point as well. I really want to show how my virtual machines relate to the underlying storage environment. I need to be able to essentially figure out exactly what devices my VM is dependent on, and figure out, in case of maintenance windows, what array I need to go look at, what disks are failing, and stuff like that. So troubleshooting issues obviously is problematic. In certain environments, we've come across scenarios where there are multiple administrators, somebody who manages storage, somebody who manages virtualization, and then you really have to coordinate and try to figure out what's going wrong when you need to troubleshoot. So in a sense, what we're trying to avoid is this Marco Polo kind of situation where you're really trying to find out where your virtual machines reside, or given an array, you're trying to figure out what workloads or what virtual machines are deployed onto it. To that end, essentially we invested heavily in sort of building our storage infrastructure in the VMM 2012 release. And this is a high-level architecture of how we went about doing that. You'll notice on the right-hand side, the top of the screen, there is the VDS hardware provider. So we essentially used to use that heavily for discovery of LANs, masking, unmasking, and stuff. And this was deprecated in the VMM 2012 release. So instead of this, we essentially started relying on an industry standard way of doing it. We leveraged SMIS, or the Storage Management Initiative specification. And we started working with our partners in the industry to basically come up with these SMIS providers. In the bottom left screen, of the screen, you can essentially see an SMIS provider. So the way VMM interacts with these providers is, you install a provider on a box. The provider itself manages a bunch of arrays, and VMM interfaces with the provider to basically perform tasks such as discovery of the array, its capabilities, pools, creation of LUNs, snapshot, clone, masking, unmasking, and stuff like that. So now what's changed in SP1? We really wanted to build on this foundation, and what we did was we deprecated and completely removed the VDS hardware provider-based infrastructure. We streamlined all of our operations through the storage management service, and we're leveraging heavily the SMIS providers that our partners have built. So the good news is any provider that already exists will continue to work. We maintain 100% compatibility. The caveat here is if you actually had a bunch of VDS-based hardware providers, VMM won't really be talking to those anymore. We would be using SMIS to essentially manage those arrays and devices. In a nutshell, what has changed is that Windows Server 2012 itself now has this storage management API. So what has happened in Windows is now there is the ability to essentially manage storage devices in addition to the storage spaces functionality that has been delivered in Windows 2012. All of it through a single consistent API called SM API. So VMM has also changed to essentially leverage that API. So you'll notice that instead of us having a lot of that infrastructure inside of VMM, it's now available as a platform capability, and we are able to leverage it similar to other tools. So the Windows Server Manager tool is another good example. It also uses SMIS for discovery and provisioning of LUNs. At a high level, the storage architecture, so to say, of Windows Server 2012 looks like this. And the goal here really is that the File Server Manager, System Center, VMM, and any other third-party management application can really use this consistent storage management or SM API layer. And under that, you have a bunch of providers. So you have these SMIS-based providers. You have third-party providers, which our array partners have shipped. And you also have SMPs, which is a storage management provider. For instance, storage spaces is exposed using that. But all of this is essentially accessible through a single central interface called SM API. And we in VMM leverage that to do a lot of our storage management tasks. So I'll give you a quick demo now of some of the discovery and mapping capabilities that we've built in VMM. It's going to be a PowerShell-based demo, just to show you what capabilities we've built. Great. So this is the VMM console. Just a quick show of hands. How many of you are familiar with VMM 2012, have deployed it, have used it for managing storage? Eric, you don't count. Eric's the dev lead who builds a lot of these features. So great. So I'm going to assume that we don't have a whole lot of familiarity with that and give you a quick walkthrough of what we have here. So you'll notice that the storage tab here essentially has three sections: classification and pools, providers, and arrays. So like I mentioned, we essentially work through SMIS providers to be able to actually discover the arrays and to provision and manage them. Let me first give you an example of what this looks like. So here I have a machine on which I've installed the NetApp SMIS agent. So this is just an example. Similarly, on different boxes, you would have to install these providers, these agents, so that they can actually talk to the array. In this example, I actually have a NetApp box, and I have the SMIS provider for that installed on this machine. So I'm going to switch back to my VMM console and show you sort of how to add, how to add the array essentially. How do we do discovery? So discovery is very simple. You essentially specify the IP address or the FQDN, of the provider. In this example, I'm going to use the NetApp provider. So I'm going to select that from this list. I have a run as account, which essentially gives me credentials to access the array. When I hit next, it is going to go out and query the array. And so, for instance, this provider manages one array, the FAST2040, and it has a pool called aggregate 0 that's available. When you hit next, you have the ability to essentially classify that pool. And I'll get to classification in a bit. But once you essentially hit next, you get a list of all of the pools that are available on the device. And once you go through the wizard, these start to appear in VMM. Now, in this case, I've actually already got this array under management, so I'm going to hit cancel and sort of get out of here. So once you have these providers essentially discovered, they show up in this list here. Every provider shows up in the list, and the one we just talked about, the NetApp provider, is essentially the bottom of that list. So VMM keeps track of that provider. It checks to see if it is responding, and all storage, automation, and management tasks are channeled through that provider. You'll also notice a section for arrays. Now, this is where all the arrays that we discover and manage using these providers show up. So, for instance, here we actually added the FAST2040 NetApp array, and that shows up in the list. So again, VMM keeps track of it. We are able to discover the pools, provision LUNs and stuff using that SMIS capability. The third thing I wanted to talk to you about is called classification and pools. So we've essentially built this higher level abstraction on top of arrays, LUNs, and storage essentially to provide a good abstract view which you can actually present to your end users. And I'll sort of leave it at that for now, and we'll get back to classification, talk about it in a little more detail. So with that background, I'm going to drop into PowerShell for a bit. And so here I'm going to show you the PowerShell way of essentially getting a list of providers on the box. So here we essentially use get storage provider. This is a VMM PowerShell commandlet. And it tells me the different providers that are registered on that box that VMM knows about. And you'll notice there are two types here. There are SMIS and SMP-based providers. So we have a whole bunch of arrays, and then using this, you can actually get more information about each array. Okay. So I'm a very lazy guy. I'm going to actually use start demo, and I'm going to run you through a demo which will essentially show you how we pick a SAN VM, a VM which is stored on SAN, and then we'll walk through right down to the storage. So we're going to try and figure out where the VHD for that VM is stored, what is the array which is providing that storage, and we'll essentially see how we can map that end to end. So let's start off with this. First, I issue get SC virtual machine, and I'm basically getting some information about my SAN VM3. This is the VM for which we're going to get some information. So from that, we get a list of information about the VM, and specifically, we are interested in virtual disk drives here. So we notice that there is one disk drive that's attached to the VM. Let's actually take a closer look at that. So we get some more information about it. We specifically know that it's attached to the IDE bus, and the object type is basically a virtual disk drive. Now the next step is to see what VHD is providing the storage or is being mapped as that virtual disk drive. So for this, what I do is from the VHD object, I can actually get the virtual hard disk object from it, and that gives me more information about the VHD. So you'll notice here that this is actually stored on a CSV volume, C:cluster storage volume 2, and that's really the host volume on which that VHD is stored. You'll also notice that this is a VHDX virtual disk, and that's another new capability in Windows Server 2012, the new VHDX file format, which provides improved resiliency against failures and also allows you to create massive virtual disks up to 16 terabytes. So now that we have the virtual hard disk, we get some more information about the host volume. you'll notice that it's actually, like we said before, it's stored on cluster shared storage. Now from the host volume, we can see what is the host disk that is providing that volume. So let's dump that. We actually get more information about that and essentially get a LUN ID. Now using that LUN ID, we're going to try and find out the LUN on the array which is providing that storage. Remember, this is a VM stored on the SAN, so we're going to try and get some more information about the LUN on which that VM is stored. So you'll notice from the host disk object, you can actually navigate to the storage local unit, and you can get some more information. So you've come to know that the storage pool that provides that LUN is called aggregate 0. It's got a classification of demo, and I'm going to talk about classification in a little more detail a little later. But from that, you can essentially get the storage pool, and from the LUN, you can get to the storage pool from which that LUN has been provisioned. So here you'll notice that that LUN is now being provided by an array called FAST2040. So what we've done is from the virtual disk drive, we've gone all the way to the LUN, we've gone to the pool, and we've tried to figure out what is the array which is providing that pool. The next step is you can essentially get some more information about that array, about what is the capacity available, whether it supports cloning and snapshots. More importantly, you can also get a pointer to the storage provider for that array. So here we can actually get some more information about the provider, and that tells us which virtual machine is essentially, which host is essentially hosting that provider. Gives us more information about the arrays that it manages. So this is an easy way in which you can essentially walk through PowerShell right from the VM. No matter where it is stored, you can try to find information about where the backend storage for that VM is. And since all of this is available in PowerShell, you can really build consoles or custom dashboards and try to figure out what your topology looks like. So there's one more demo, which I actually skipped over, I guess. So this is a demo in which I'm going to essentially get some more information about the array. So I use the get SC storage array for the FAST2040 array. I get some more information about the storage groups which are available on that. I get a list of the storage pools that are provisioned on that array. From the storage pools, I'm able to list the groups. So I actually can list which are the IQNs and the targets which are available for that array. Now, I can actually list the initiators in that storage group. So a storage group is really a mapping between initiators and targets. I'm listing the list of initiators here. The next step is we're going to actually approach it from the host side. From the host side, we're going to dump some iSCSI information and try to find out what are the IQNs available on that host. So here we get a list of those IQNs. The next step, we're trying to do a mapping between the array and the host. So we can actually walk through the list of hosts and try to find out the one that matches that initiator. And so we find out that it is essentially VMM Lab 823N3. That's the machine that is really mapped to that. So this is another example of how you can essentially walk from the host side, get a whole lot of information that VMM maintains on the host side, and correlate that with the information we collect from the array side, and sort of figure out how the initiators and the targets are mapped together. Okay. So let's sort of move on. So there are a bunch of new storage management providers that are available. We already had SMIS, SimXML based providers, so we really could support these arrays in the VMM 2012 release. So NetApp, EMC, HP, IBM, Dell, and others. What's new in SP1 is the ability to essentially talk to LSI MegaRAID through the SMIS based WMI provider. What's also new is the support for SMP-based or storage management provider-based providers. And we use that infrastructure to talk to Dell, EqualLogic, and Nexan arrays. So you'll notice that with the changes that have gone into Windows Server 2012, with the ability to actually have a consistent SM API-based interface and multiple providers below that, we are now able to actually talk to a lot of these disparate devices and get information from them and provide a good unified storage management experience. The other new capability essentially in this release is support for iSCSI SANs. So we essentially are now able to support the HP left hand and the Dell EqualLogic arrays. So we had a bunch of the support already in the previous release in VMM 2012, but we really didn't handle dynamic targets really well. So there were scenarios where for certain arrays, for every LUN, it would have its own target, and it would require that the initiator be logged on to that target. VMM really used to think of it as just a single target for all the LUNs, and we'd expect to be accessing any single LUN through that target. What's changed in this release is that we are now aware of dynamic targets, and we'll automatically log on the initiators into the right set of targets and make sure that we handle that correctly. SAS. So we also have enhanced SAS support, and essentially we are able to do the same tasks, which is discovery and provisioning in terms of the capabilities we also offer for other storage arrays. We can also offer that for SAS. So attach, detach, storage provisioning, creation of LUNs, discovery of pools and attributes. So we can do all of that in VMM 2012 SP1. Specifically, this adds support for the HPP 2000 and the LSI engineer. Now, just a quick walkthrough of how you can actually do mapping. So we sort of do this in multiple levels. So we have a first level discovery on the storage side, which gets you information about, in case of the block storage, gets you information about the pools that are configured on that storage device, the target ports. And now in Windows Server 2012, we also start to manage file servers, because you can have your virtual machines on SMB storage. So for the file server, we're able to get information about the backend file system. In the second level of discovery, for block storage, we can essentially get you a list of LUNs, get the initiator IDs, the storage groups which maintain mapping between the initiators and targets. And for the NAS case, or the file case, we can essentially get the file shares and the permissions that are granted for that share. Now flipping over to the host side, VMM already has a host agent, so we collect a lot of information on the host side as well. So in case of FC, we can collect port, vport information. For iSCSI, the IQNs, like I showed you in the demo before. For SAS, we can get the port information. Similarly, we collect information through VDS for the disks and the volumes on the host. Now what happens is, and this is probably not going to come through in the demo, but in the slide, sorry, but we can actually create mappings between the host side and the backend storage. So you can essentially see how your pass-throughs and your VHDs are mapped essentially to the storage. Okay, so I had another couple of demos. Let me just switch to that. Let's end the second demo. Now in this demo, we are actually going to take a look at what happens if your VHD is stored on a file server. So I'm going to actually have a scenario where I have a VHD that's stored on a remote Windows file server, and I'm going to actually map how that VHD essentially is mapped to the Windows file server, the share on which it resides and stuff like that. So let's start this demo by, again, getting more information about the virtual machine. So we issue the get sc virtual machine commandlet, and we get more information about the VM. From that, we figure out that it actually has a single disk drive, that is virtual disk drive, that is attached to it. If you inspect the virtual disk drive, you get more information about the virtual hard disk that is actually backing it. So let's do that now. So we notice here that the virtual hard disk, the VHD that is backing it up, is actually a VHDX file, and it is stored on a file share. So the file share here is VMM lab gen FS1, and the share name is file share 01. So you'll notice in this example, we have a virtual machine that is being stored on a remote SMB share, SMB 3.0. Now what we can do is essentially get more information, try to get more information about that share. So as of the CTP2 release, we don't really have objects in VMM for the share and for the server. That is coming in the beta release. So for now, what we're going to do is actually drop into the Windows Server commandlets and try to use the get SMB share, which ships with Windows Server 2012, and try to get that information. But once VMM hits beta, you should have all of this capability inside VMM, where you can actually take the VHD and use that to find more information about the share and then the server, the file server that actually hosts that share. So what I'm going to do here is essentially parse the path and try to figure out what is the share name. So the share name here is file share 01. The next step is to parse the path again and try to figure out what is the file server name. So I get the file server name here. Now using this information, I actually feed the get SMB share Windows commandlet, PowerShell commandlet, and I can get more information about that share. So here the share essentially shows you what is the volume on which that share is located, the state, whether it's clustered or not. In this case, it's a clustered or a highly available share. And it also tells you whether it is continuously available or not. So we're also adding support for third-party NAS devices, so you'll essentially be able to do this against your NetApp or your EMC boxes, which also have NAS support. Now I'm also going to get some more information from the cluster, and that's how I can really figure out what node that file server is really available on. So that's a very simple demo in which we've essentially walked through a scenario where a VM was stored on a file share, and once again we were able to walk from the VM, figure out the list of virtual disks, find out what is the backing VHD, figure out the share on which it is located, and then get more information about the file server. So again, all of this can feed certain tools and dashboards that you need, or also can just help you figure out or make sense of storage when you're really deploying at scale. Okay, I have another variant of this demo, which is essentially the exact same thing, but we're going to do this with a scale-out file server. So I'm going to go through this really fast. Once again, we start with get SC virtual machine. We get more information, figure out what are the virtual disk drives attached to it. From the virtual disk drives, we try to find out what are the VHDs attached to it. We get more information here. We figure out that it's actually, again, stored on a file share. From the file share, we try to find out what is the share name, what is the server name. Again, very similar to what we just did. And now you'll notice that get SMB share actually tells me that the file server has an availability type of scale out. So this virtual machine is stored on a scale out file server. So again, this is another example of how you can use the VMM and the Windows PowerShell commandlets and sort of use that for end-to-end mapping. Great. So let's sort of switch back to the deck here. Now, once you've actually figured out a way in which you can, sort of get more information about your storage, get the mapping between your virtual machines and storage. Another interesting thing is VMM essentially gets all of this information from the provider, the SMIS provider. The question we were asked is whether that's a one-time task or whether VMM really keeps refreshing that information in. And VMM does refresh it every 1 hour as of VMM 2012. But what could happen is you could actually have these things change on the back end, on the storage array, where someone might use a SAN tool or another storage management tool and change information like masking, unmasking, LUNs, and whatnot. So in order to sort of solve that problem, we rely on something called lifecycle indications. In WMI speak, you can sort of think of it as events. So when something actually changes on the back end array, we get that information through the SMIS provider, and it propagates up into the caches of the SM API service, the storage management service. And that is how VMM essentially gets to know that something has changed. So in near real time, we can sort of figure out that something has changed and reflect that information, propagate that up in the VMM console. So this is another new capability that is shipping in 2012 SP1. The next step is storage classification. So now you've figured out a way in which you can actually make sense of how your storage is laid out. You have provisioning capabilities from within VMM. And now you want to actually use that storage. You want to give it to self-service users, and you want to have them consume that capacity. So VMM has this notion of storage classification, where you can take storage across multiple arrays or disparate storage devices and tag them or classify them based on SLAs or performance that is associated with it. So for instance, you could call it gold, silver, or bronze storage based on the kind of SLAs or the kind of devices that provide that storage. Now this storage SLA is essentially a much simpler way for an SSU user to actually deploy their virtual machines. So they don't really need to understand LUNs and storage arrays, different types of it, figure out exactly where to place their virtual machines. They simply understand what kind of performance SLAs or guarantees they want from their VM. So if it's an important VM, for instance, they can actually deploy it with gold storage. So for each VHD, you have the capability of selecting classification. So in NetApp speak, you essentially see the pools show up as disk groups. Sorry, that was HPEVA. In the NetApp world, essentially shows up as aggregates. In the EMC world, it shows up as pools. So what we do essentially in VMM is we sort of aggregate all of this, and we give you this notion of a storage pool, and multiple arrays can be managed by VMM. And you can essentially take pools and classify them. So for each pool, you can say, this is backed by SSDs, for instance, and therefore this is my gold storage. And this storage can then, this classification can then be allocated or assigned to self-service users, to clouds for self-service users to consume. So that brings us to the next step. How do I actually allocate and assign the storage? So once I've created logical units, I've basically provisioned them from VMM. And in 2012 SP1, you'll also have the ability to create file shares. So once you essentially do that, VMM has this ability to, in terms of file shares, when you actually create a file share, let's say the file share is created on a pool which is in gold storage, VMM will automatically classify that file share and mark it as gold storage. So we really have this ability to classify storage, and then you can assign that storage to either host groups or to the clouds that make up that host group. VMM also takes care of things like initializing disks, partitioning them, and performing volume level formatting. So let me quickly show you how that's done. So for this demo, we'll essentially, we're in the storage classification and storage pools view, and we've clicked on allocate storage. So we have two wizards here. We have the allocate storage pools wizard, where you can take a bunch of pools and you can essentially allocate that storage out. And it's really very easy. All you have to do is select it here, click add, and then it gets allocated out, right? So in this case, I'm going to actually cancel out of this because a lot of my storage is already allocated. Similarly, you can actually allocate logical units. It's the exact same thing. You have a bunch of units which are already allocated. You can choose the hosts or the clouds that you want to allocate and then pick and choose it. So all of these are also supported through commandlets. And it's really very, very easy to do. Now I'm going to quickly switch over to rapid provisioning, and Amit's going to take over here. And there are a whole bunch of really exciting capabilities that we've added both in rapid provisioning and some of the other capabilities in VMM. So Amit.
Right. Thank you, Mahesh. All right. So I hope everyone has had their lunch, because the next few slides and the demos that we're going to go through are going to be some sweet treats. And I hope all of you have a sweet tooth. All right, so let's start with this. What we really heard from our partners and customers are that I wait for a long time for my storage to get provisioned. Now that the pools are there, the storage is there, the hardware is there, what do I do to actually create my VMs on this storage? Some of the people who we actually sent a survey to said that we don't even have any expertise to actually do this automation. It's not that everyone cannot do it. There are 14% of people, when we actually sent out our surveys, those 14% of the customers said, yes, we can do it. But the remaining people said, I don't have the expertise. Among the other ones who could not do it, they were like, I have the expertise, but I think there are way too many APIs, and I really don't know which ones to use, which ones are more, how do I actually build up my storage? I really don't have that. And then the others who actually were able to automate did it so that they can avoid any human errors, human intervention, no fat fingering, and everything can be completely automated. Now, what we have done here as part of rapid provisioning is to be able to get all the way to the cloud. So what we do is we allocate storage to your host groups, which feed into a cloud as one of the components in terms of compute, storage, and networking. Once your cloud is ready, it's ready to be given to our delegated users or to the self-service users. You give them quota, you give them capacity, and you actually ask them to create their VMs on top of it. So if you look at the new stuff that we're doing as part of storage provisioning, we have thick and thin LAN provisioning. Thick and thin LAN has always been there with VM 2008 R2. The new things that we have actually added here is at the time, if you have a thin pool and you actually want to create a thick LAN, we allow you to actually override it. The other thing is storage masking. We allow you to do creation, deletions, and modification of these masking sets. The new thing in SP1 is going to be file server management. So VMM 2012 SP1, as part of System Center 2012 SP1, is going to be supporting SMB Share 3.0. And these could be Windows Server based or Windows File Server based, or these could be external NAS devices, like the NetApps or EMCs of the industries. So as Mahesh already walked through the allocation of the host group and the cloud management. Let's actually go into the actual rapid provisioning. First thing is, why would I really want to do any storage automation? Like I said, if you already have all your pools, now all you want to do is use that pools to actually go ahead and create these VMs. The VMs could be backed up by storage, which could be going on standalone host, or could be going into a cluster for them to become highly available. The only caveat is that you would have a 1 VM per LUN restriction, because we want to be able to migrate using SAN these VMs as well. How do we do it? So what we have is, we have a VHD which we market as SAN clone capable. Think of SAN clone as, for example, flex clone in NetApp, which gives you the optimization of creating a flex clone at a faster pace, being able to put it onto a host, and then being able to mount it. What we do is we mark the VHD as SAN clone capable. We use this recipe to build up our template, and you actually get a SAN clone capable template. Now we try and move the template into a host. So we run through a new VM wizard. The SAN clone VHD that we have gets copied over, or the flex clone or the snapshot, whatever the RS supports, get created. It gets mounted onto the storage, onto the host. And then finally, we create a virtual disk out of it. So the VHD is already present there, and we associate it to the VM. I'll actually give you a quick demo on this through the UI from VMM. The next part is, I have my VM created. Now I want to leave it there. I don't want it to actually come out of the SAN. So the mantra is, once on SAN, always on SAN. Be able to, whether you want to do a migration from a host to a host, whether you want to move it from a host to a cluster, you want to move it from a cluster to another cluster, you want to store the VM into the library, we handle all these migrations using SAN. The only thing we don't do, and purposely, is to be able to do storage automation migration between a VMware and Hyper-V. We want you to be able to create VMs on Hyper-V and utilize storage automation. The things that we do with migrations are masking, unmasking. If you have fiber channel, so we basically just unmask the LUN from the source host and mask it to the target host. We also take care of iSCSI initiators, log-on, log-offs. So imagine things like Dell EcoLogic or the Nexans. We actually do log-offs, log-on into the target from the initiators. If you are using HBA cards, which are virtualization capable, we also do NPIV vport creation deletion. So imagine your VM is created on an NPIV port on the source host, and when you actually migrate the VM onto a target host, we delete the vport on source and recreate the target port on the destination for your VM to actually get migrated. A new feature in Windows Server is ODX. So think of it in terms of SCSI commands, SCSI xcopy commands. And ODX is basically a SAN copy optimization. If your array supports ODX, you would be able to use ODS or leverage the optimizations that ODX gives you right from VMM when you do a live migration or when you do a live storage migration on a Windows 2012 server. All right, so enough of talking. Let's actually get into the demo. So the first thing that I'm actually going to show you is, where is my VHD? So let's go to the library. For people who are not familiar with the VMM console, we have these tabs for the VMs and services view, for the fabric, for the library, and for jobs. So I'm going to take a look at the library. I'll scroll down here. I go into my library share or the server that I've added. And these are two VHDs that I already have imported into my VMM server. Now let's take a look at the file locations. Now this is the server. This is the share that is being shared out as a library share. These are two mounted LUNs on this particular library. So what I've done is I've created a SAN copy capable VHD which can show up in my library, and I'm going to use this to actually create a VM using SAN. Right, so this is the mounted LUN, and the VHD resides inside this. All right, let's switch back to the console and go ahead and create a new template using this VHD. So I select the VHD, I go to my ribbon, and I say create a VM template. It asks me for a name. Let's give it a name. Now if you notice here, this is our hardware configuration page, and it actually shows you the VHD that we selected right now. It also asks you to enter a classification. So what Mahesh was talking about earlier is we allow you to classify your storage based on the pools that have been added. So our self-service users are not really going to come to the administrator and say, hey, I really want a storage pool called pool 1023. What they really want is, I want my VM to be backed up by gold storage. And that's how you actually go ahead and classify your storage, and you can specify that at the time of your VM creation or a template creation. So I go ahead here, I select the demo classification that have been selected, and this is the only change that is needed in a VM template with regards to storage. I already have a template pre-created to avoid the additional steps to go through, so let's go ahead and use that. Now this is the VM templates view, and here is my template. Let's take a look at the properties to ensure that it is actually using the same VHD and the same classification. Go to the hardware configuration page. This is my VHD, and it has the same VHD that I just showed you. It is using a demo classification. Let's go ahead and use this to actually deploy a VM. So I select the template, click on Create Virtual Machine. It'll ask me for the name of the virtual machine that I want to deploy. Let's call it a TechEd demo VM. Go through the next page. Here, everything is the same. I don't have to change anything. Next page will ask me whether I want to deploy it to a host or to a cloud. Now, if it is being deployed by a self-service user and they have the option of being deploying to a cloud, then we would, under the covers, take care and make sure that if the VM or the VHD is actually on a SAN, they actually will be able to deploy it only using SAN. My intelligent placement runs, so the VMM intelligent placement runs here, and it makes sure that my hosts get positive stars. And if you notice, there's an extra column or an additional column out here called transfer type. What this really tells you is that the VHD would be copied from the library onto the host using a SAN copy or a clone, instead of actually having a network copy all the way from my library into the actual host. The reason the last host gets a 0 star is because I'm trying to use it into a cluster. I'm trying to use an HA flag. Hence, the first 2 nodes are my cluster nodes. All right, so let's just select the first node. Go ahead. This is our specialization page where you can actually select and say what location you want your virtual machine to be created. Because my virtual machine is being created in a cluster or into a cluster using SAN, I really don't need any location. Because what I would do is, or what VMM would do is, it would actually take the LUN, unmask it to both the nodes of the cluster, make it a clustered resource, have the VHD there, make your VM, make it an HAVM, and associate it with the VHD. So I really don't need any location for my VHD or for my VM to be transferred when into a cluster. So let's leave it blank. Let's just go ahead. Ask me for a network. For this case, because I'm not really doing any domain customization, I'm going to just have it not connected. And that's it. I just have to go to the next page, make sure everything is fine, and just click next. I'll actually go through and will deploy your VM into the cluster. Let's quickly take a look at the jobs and see what it actually does. So what we are doing here is we are making use of SMIS provider and the service that Windows ships. We're going to be calling the provider talk to the array, create a clone for this, and actually go ahead and deploy this VM into the cluster. Oops, something failed. All right, so the idea here was that the VM that actually gets created goes all the way into the cluster, becomes a cluster resource, and actually you will be able to then show it up as an HAVM with the cluster already added into the LUN already added into the cluster. All right, let's move ahead. The next thing we have done with regards to storage investments is array onboarding. Now with Windows Server 2012, we have huge investments where we are talking about 64-node clusters. How do you actually onboard a 64-node cluster today? If, let's say, you are using an iSCSI storage, you actually go to each of the nodes, you log in, you enable first the iSCSI initiator, you log in from each of the node into the target, and then you try and bring it and do it on all the 64 nodes, and then the cluster actually comes online. What we do with VMM is we have automated all this process from VMM. So, and we also make sure that we make these as persistent iSCSI sessions. We add it to the favorites, and once it's done, it's over. You don't even have to go to each of the cluster nodes and touch it from there. We also allow you to create an SPC or a SCSI controller port per node or per cluster. There are quite a few customers who actually do it of quite a few arrays which support it per cluster. And the reason to do it per cluster is the masking, unmasking to a cluster takes a long time. So if you just have one SPC per cluster, you can actually do it quickly and just have it onto the SPC. The reason you would do it for a node is if you want to have an asymmetric storage and you really don't want your storage to be provisioned to all the nodes in the cluster. The other thing we also do is cluster storage management. So from VMM, you could actually go ahead and be able to provision storage into the cluster. We will take care of creating a LUN. We would take care of mounting the disk, unregistering the LUN into the cluster, mounting the disk, be able to create a volume, be able to partition it, either do a quick format or do a force format, create the file system on top of it, and even be able to convert it to a CSV. And we'll walk through that also right now. All right, so let's go back to the Fabric view. And what I need to do first is I'll allocate capacity so that I can use that to actually create these volumes into my cluster. So I go to allocate capacity. I click on allocate logical units. Let's go to the pool that we were actually using. So these are the 3 LUNs that we had created earlier, or I had created earlier for demo purpose. I'm going to take all these 3 and I'm going to put it here so that these are allocated to my host group. All right, so this is done. Now I go into my clusters. So I go back into the Fabrics view. I expand my servers. And this is the cluster out here. Let's select the cluster, go to the properties of the cluster. And we go into shared volumes. Here, I see all the 4 disks that I just allocated as capacity. The 3 disks and 1 was already allocated. So let me just select all the 4 nodes, all the 4 LUNs here. I will just do a quick format because these are pretty small LUNs. And because I'm already adding them as shared volume, they will automatically get registered and provisioned as a CSV. So let's go here, click OK, and we will go back into the cluster UI and make sure that there are only 5 disks here. Slowly the other disks will also appear here. Let's go back into the VMM view. Let's go back into jobs and look at what we are doing under the covers. So what we are doing here is all the 4 LUNs would get parallelly unmasked to the host or to all the nodes of the cluster, and they would be brought up as clustered volumes or clustered shared volumes. So slowly these tasks are going ahead. All right, so we'll come back to this and we'll make sure that the clustered volumes have been registered there. Let's move back to our slide deck. With VMM 2012 SP1 and with Windows Server 2012 with Windows Server 2012 coming out, we have a ton of commandlets that are there for our customers or partners to actually use and build entities on top. So VMM itself has around 25 storage commandlets. The Windows has around 85 storage commandlets. The idea here is that either you can use VMM to actually automate your storage, or you can actually build your own tools and leverage the use of SM API and actually come up with external tools or your own applications. We have also worked with industry partners like NetApps and EMCs to actually work on scale, to be able to increase deployment at scale. Imagine having a 250 VM on using SAN on a cluster. For those of you who actually manage clusters, having 250 LUNs on a cluster is not a small deal. You have issues with VDS, you have issues with cluster, you have issues with the host. So we are making sure that we actually work with our partners, Windows, external partners, the array vendors, the hardware providers, and make sure that we actually iron out these issues so that we are ready for the enterprise at scale. What we have actually done is we have a lot of block storage, so that's not new. The new things that are coming in now is all around file storage, and the new commandlets around Windows Server 2012 SM API. Apart from this, we have made a lot of investment within VMM itself to actually do the UI add-in stuff, where we let you as a partner or a customer be able to extend our UI and actually have you create your own portals, you create your own tools that you can invoke from our UI itself. We have pass-through capabilities, which is a feature of SM API, but there are certain properties, or there are certain functionalities that you can actually get from pass-through instead of the SM API. For example, think of NAS management. Think of managing NAS devices like NetApp or EMC that you can actually get all the way through pass-through. The Windows Server commandlets themselves, the architecture itself gives you REST endpoints, or it gives you external commandlets, WMI and PowerShell based, that you can actually go ahead and implement your own certain tools. I'll give you a quick demo of the UI add-in that we have created here for demo purposes, and that just will give you a small glimpse into how powerful that can be for you to be able to build your own specific tools. So let's switch over back to the demo. All right, so this is still going on. Let's go into the settings. And if you actually look at, this is a 2012 SP1 CDP2 build. So if you look at an option here in the ribbon, it says import console add-in. What you do here is you actually go ahead and you browse and you add a zip folder or a zip file which has your own commands, or which has your own exes or your own PowerShell, what you will, that you can add it here into VMM. So for simplicity, I've already added it here. So if you look at this, my console add-in already shows up here. So what I'm going to do is I'll go back to my fabric layer, and I'll go into my storage view, go back into the arrays. I have a fast array here, and if you look at this, there's a context menu also added in the ribbon for the show array dependencies, and we also added into the right click menu here for you to be able to add these executable commands. So let's click on array dependencies, and what it does under the cover, it is actually invoking a simple batch file which is calling a PowerShell commandlet, and it's using the NetApp storage stencils to be able to create a simple visual diagram of whatever Mahesh earlier showed you from PowerShell. So all we are doing is showing a visual representation of the same thing, of walking up the chain from an array into a VM right here from VMM console by using an external entity. So let's go into the VMM, into the visual diagram. Let me minimize these. I'm going to zoom in a bit more so that it becomes clearer. And if you look at it here, let me zoom in a bit more. So what it has done is it shows you the VM called mySAN VM05, or for example, the VM that Mahesh was showing earlier, mySAN VM03. It tells you which volume it is on, so it tells you it is on a CSV. It also maps it all the way back to the LUN, and then downwards, it actually maps it all the way to the array. If I can get it here. There is the pool or the aggregate that we had actually selected, and which gets mapped down to the array itself here. So if you look at this, you can think of it as a tool that you can utilize to actually create any UI add-in that you want. All right, so let's go back to the VMM view. Let me close this. Let's go back to the VMM console to make sure that our cluster provisioning job has finished. All right, so the change host cluster is done. I'll go back to our VM view, to the cluster view. If you look at this, we had disks. We had only 6 disks, and now there are new disks which shows up here, which have been provisioned all the way from VMM, and these have automatically been marked as a CSV. So if you look at the simplicity with which you can go to VMM, allocate multiple LUNs at the same time, make them a CSV, or convert them from a CSV to an available storage, or vice versa, right from VMM console. So when I was talking about the storage commandlets, we were talking mostly about the SM API commandlets that Windows Server 2012 that itself ships with. So if you look at it, they have a huge variety of number of commands that actually can be utilized. So we have around 82 to 85 commandlets that ships with Windows Server 2012. And they go all the way from a virtual disk management, which is in our speak a LUN, to a physical disk management, partition volume, masking set, and storage pool. So you can actually go ahead and create storage pool right here from Windows Server 2012 from the platform itself. The links, once you get access to the actual slide deck, would actually points you to Microsoft and MSDN, and it has all full support with the documentation of all the commandlets. Now, one thing to notice here when we are talking about disk, physical disk, and partition is that a lot of these are also available from VDS. So now, if you see where I'm going, what I want to assert is that the SM API layer not only gives you just the automation for the pools, it also does everything that a VDS does. So it's a one-stop shop to actually build all your storage automation. System Center 2012 SP1, VMM 2012 SP1 is actually built on top of it. File Server Manager is built on top of it. So you can just go ahead and utilize all this investment that has been done from the platform side, from the management application tool side, and actually extend it. From VMM endpoint, we have had tests and we have worked with partners to make sure that we test on multiple arrays so that by the time we actually ship or we have a release going out, there are a lot of support matrices that we can actually publish. So some of these are NetApps, EMCs, HP Dells that we are still working with, and there are some of them which have their providers in progress. Since SM API or SMIS is more of an industry-based standard, we do a lot of work by going to the SNIA Plug Fest. So there have been around 5 Plug Fests per year in the last 2 years, and we have been present at all these Plug Fests with SNIA. So if you go to snia.org, you could actually find out the partners who have been available there. You could get more information on what has been done. The other thing is we are also SMIS 1.3, 1.4 compliant, and we are also working towards with the new providers and with the new partners that are going to be added. So on a quick look, let's look at what are the other things that we have done. To be able to extend our support to multiple providers, what we have done in VMM is we have built our own test harness tool that we give to our partners and customers to make sure that they can verify and validate that their arrays are compliant with VMM and storage automation. So we have a huge test bed that we have actually built, and these test all the way from simple operations like a simple LUN clone, a simple LUN creation, to advanced flows like mounting a disk, being able to create a CSV, to all the way from doing an end-to-end mapping, from taking a VM all the way from a SAN LUN library to be able to create a VM and actually have it rapidly deployed and be able to do a SAN migration. So I'll also quickly show a quick snippet into the actual storage test bed. But before that, let's look at the providers that we are already working with. So these are the SMIS providers or partners that we are already working with. So you see the EMCs and NetApps and Hitachis out there. These are the other partners that are in progress or are working in development. So you see one Dell EqualLogic, which is actually building an SMB provider. We also have Nexsan, which is actually helping us build an SMB provider. So we're already working with them to get all of these tested and give them our storage test beds so that they can actually go ahead and also be able to do a lot of testing on their end.
Just a quick question. So if you actually have an array or a vendor that you're very interested in and that's not on that list, please do let us know.
So recapping on what we were already talking about, these were the fantastic 12, which goes all the way from being able to do a disk mapping, to be able to initiate or to be able to get the storage groups or masking sets into VMM, map it to the VHD, to the disk drive, to the VM themselves, to be able to rapidly deploy a VM, to keep the VM on the SAN, to be able to deploy storage onto a cluster, and also to be able to actually do some validation and scalable provisioning. The way we actually look at this is we categorize them under 3 themes. An insight, which gives you on mapping these, being able to define classifications, being able to do allocation and assignments, and you can do it on your own terms. You can actually onboard these arrays. You can actually have extensive array supports. You can do storage automation. And the ease of use. Once on SAN, always on SAN. You can do a SAN migration. You can rapidly go ahead and deploy a VM. Or you can also be able to do cluster storage management and go ahead and in one shot be able to deploy multiple LUNs or multiple volumes into the cluster and make them as CSVs at the same time. These are some of the external sessions that are still going on. We have one more for VMM 2012 SP1, which is on network, which is going to be happening just after this. So let me switch back I'll get back to this slide again so that you can take a look at it. But let me switch back here and show you the work that has been done with regards to the storage bed. So here is a simple storage validation script that we actually ship to our partners. And if you look at this, this is a huge PowerShell script with around 4,000 lines. One of the easiest ways to learn all these storage commandlets is to actually take a look at this particular storage PowerShell file. What we do here is we have different tests and different functions that have been dedicated here, and we use a config file to actually initiate this. So our partners, what they do is they just go here, specify what kind of an array they have, what kind of provider they have, where is the provider located, what are the tests that they are interested in, which is the pool that they should be bringing under management, how many scalable or parallel operations that they want to run. They can just specify it all here, and we would take care of running all of these. You can also go ahead and say specific tests that you actually want to run. Instead of running all the tests, you can start from very basic with just, let's say, clones or learn creation or learn snapshotting. Once you're good there, then you move ahead to make sure that these can be mounted. Once you're good there, then you go ahead and make sure that these can be created as a CSV. Once everything is done, then you actually go into full end-to-end mapping. So a simple PowerShell invocation would be something like this. We take care of preparing your environment through the config that you have provided. So you would create all the SAN LUNs that you want in the library just through the script. All you have to provide us is just those parameters. We go ahead and also you can select which tests you want to run. So the tests are also classified as in terms of levels, like hundreds are tests which are very simple. So we just create simple VMs or simple LUNs. And you can go all the way to create it as at level 200 tests, which will actually go ahead and create VMs using rapid provisioning. And at the end of the day, after you're done with all the tests, you can also invoke the cleanup environment right here from the PowerShell commandlet tool or from the PowerShell commandlet script, and go ahead and clean up all the environment that you had that were created at the time of rapid provisioning.
Yeah, it's a significant investment to make sure that our partners essentially come up with high quality providers so that they kind of work with all of our VMM workflows. And we're starting to see some benefits from that. We're starting to see some pretty high quality ones from our partners.
All right. So that was pretty much what we wanted to talk about storage. And like Mahesh said, if you think that there are partners here that are not there or that we haven't listed out and we are not working with, please do let us know so that we can initiate a conversation with them, or we can initiate a conversation with you so that we can make sure that by the time we ship SP1, we have enough support so that your data center, your enterprise can actually be storage managed through VMM. So we'll be here for any questions in case if you want to ask right now, or if you want to come over and ask us, do let us know. So right now, do you have any questions that you would want to find out or ask? All right. Please do stop by or come over if you have any questions.